Here is a question on 90 laws of viscosity. A plate 0.05 meter square distance from a fixed plate moves at 1.2 meter per second and require a force of 2.2 Newton per meter cube. To maintain this speed, find the viscosity of the fluid between the plates. We have to calculate when you have a distance of a plate of 0.05 meter square distance from a fixed plate moves at 1.2 meter per second and require a force of 2.2 Newton per meter square. To maintain this speed, find the viscosity of the fluid between the plates. So we have to find the viscosity of this. And remember, according to our Newton laws of viscosity formula, we said that we are being given given that we are being given a distance of the plate, which is a distance of the plate is our dy. I said that our dy is our distance of the plate, which is dy. So we have our dy is 0.05 meter, which is meter square, and from the fixed plate move at 1.2 meter per second, which is our velocity. Our velocity is that is the change in velocity is u minus 0, the final velocity minus initial velocity, which we have our this is which was 1.2 minus 0, which was 1.2 meter per second as our change in velocity, and require a force. We have require a force of 2.2 Newton per meter square. So it means we require a force exerted on an area, which is the shearing stress, which is top, which is 2.2 Newton per meter square. So to maintain this speed, find the viscosity. We have to calculate the viscosity. This is our viscosity, and we don't have. So for us to calculate the viscosity, according to Newton laws of viscosity, we have our tau is equal to mu is equal to du over dy. So what is our tau? Our tau is 2.2, which is our shearing stress, is equal to what is our mu? We don't have. We have to calculate the mu, which is our viscosity. What's our du? Our du is 1.2. Then what's our dy? Our dy is 0.05 meter square. Remember that our unit for distance is meter, so we have to convert meter square to meter. For us to convert meter square to meter, we are going to have 0.05 divided by, we are going to divide by 1000. That is, we are going to have 0.05 meter square all over 1000 meter. Meter will cancel this and we left with meter. So I'm going to have 0.05 meter all over 1000. So 0.05 divided by 1000. I'm going to have 5 times 10 raised to the power minus 5. That is 5 times 10 raised to the power minus 5, or 0.00005. So it's in the standard form. So my dy is 5 times 10 raised to the power minus 5. I'm going to have 5 times 10 raised to the power minus 5. So from here, what can I do? I can take this one to here. I'm going to have 2.2 times 5 times 10 raised to the power minus 5 is equal to the viscosity times 1.2. I'm going to have 1.2 viscosity, which is mu. So if I multiply 2.2 times this, what I'm going to have 2.2 times 5 times 10 raised to the power minus 5. I'm going to have 1.1 times 10 raised to the power minus 4 is equal to 1.2 mu. So I want to get my mu, which is my viscosity. I have to divide both sides by 1.2. So I'm going to have mu is equal to 1.1 times 10 raised to the power minus 4 all over 1.2. If I divide this one by 1.2, I'm going to have my mu is 9.166 times 10 raised to the power minus 5. So therefore, the viscosity of the fluid between the plates is the viscosity of the fluid between the plates is 9.166 times 10 raised to the power minus 5. And the unit for viscosity is Newton second per meter cube. Newton second per meter cube. So this is the solution for the problem given above. So we have gotten our viscosity of the what? Viscosity of the fluid between the plates, which is what? 9.166 times 10 raised to power what? -5.